Right, we continue. We just want to see some other basic things that can be that you should know about sets as well. And the first thing is the first thing we do in this one is to talk about something being an element of a set or not an element of a set. Okay. Now, what do we mean by this? When we say that something is an element of a set, we are saying that thing that you are looking at as it is going to be found inside the set. So, for example, if I say I have a set A, that is going to be the set of numbers 1 to 5. So 1, 2, 3, 4, 5. Only the positive integers, right? Not all the real numbers, just the whole numbers, which is the positive integers in this case, or the natural numbers also. The natural numbers 1 to 5. So we have listed them. This is listing notation, remember? And this is complete listing notation. Okay? We have complete listing, partial listing, set builder. So in here we have put the numbers 1 to 5. Now, we can ask you, is 3 an element of A? Let's say you've been asked, is 3 an element of A? They are saying, if you go into set A, are you going to see this thing as it is, this 3? Yes, you will. So here you say, yes, it is. 3 is an element of set A. So we can just leave it like this to say 3 is an element of set A. Now, if we say, is 2 not, this is when you are saying something is not an element, you use E, then you slash it, right? So you can say, is 2 an element of A? Yes. So let's just say 2 is an element of A. What about if I have 7? Is 7 an element of A? No, 7 is not in A because element means it's in A. So 7, we say, is not an element of set A. Okay? You put the guy and you put the name of the set. So you'll be saying to us, this thing that we're looking at, this 7, if we go into A, we'll find it or we won't find it. If we slash it, we'll be saying we are not going to find it. Now, if you're asked to say like this, let's say you have a set, you have set B, and in set B is this symbol, which is going to be this. We're going to talk about it just now. If you're asked, let me ask you, is this guy that I'm about to put here, is he an element of set B? Is this thing an element of set B? The word element means that if you go into set B, are you going to see this thing inside set B? So I'm going to go inside set B. I will not see it. Inside set B, I will only see this symbol. I will not see this whole thing here. So that means this thing is not an element of B. Because remember, element means it is inside B as it is. No, but this symbol is an element of B. That is true. Okay, it is an element. This symbol is an element. Now, what is this symbol to represent? That's the next thing we're now doing after doing these sets. And that is just the idea of empty sets. Okay, so we would have what we call empty sets. And the other word for it is now set. And the other word for it is void sets. Okay, empty set or now set or void sets. Now, what is that? That is just a set that has 0 elements. If we have a set that has nothing in it or 0 elements, we call it an empty set. And the symbol which we use is going to be braces without anything inside, or we'll put a 0 and slash across it like that. These are the symbols we will use for empty set, but not to put that together, to put this slashed thing inside inside a set with nothing. This is not an empty set. When you do this, you'll be telling us that inside the set is the symbol, is this symbol. You'll be telling us that this symbol here is inside the set. Okay, so don't ever mix them. You only put one thing. So that's the idea. Now, you can get some very funny empty sets that from our set builder notation. In other words, let's put an example. Let's say we have the set A, which is going to be made by, we have the set A, which is going to be made of real numbers. So we say we represent it by X. We can choose X, or we can choose Y, or we can choose M. So let's choose M. M is going to be the letter we'll use to represent everything in set A. So everything in set A is an M. It is an M. If I can find an M, I would have found the things in set A. So M, which is going to be real numbers, such that now you're about to tell us what type of numbers. We know that they are real, but you tell us more about it. You can say that there would be M squared plus 1, okay, equal to 0. They are going to meet this equation. M squared plus 1 is equal to 0. So this set A is made up of all real numbers that meet the equation M squared plus 1 is equal to 0. Now let's try to solve this equation M squared plus 1 and see which type of numbers that could have been. Because if it's a quadratic equation, we can solve it. It's a quadratic equation because the highest power is 2. So we can try to solve it. Let's try to solve it. To solve this M squared plus 1, we'll take 1 to the other side. We'll have M squared being equal to minus 1. Now, the moment we get here, we already know that we are wrong, because you can't square a number and get it being positive. All numbers in the world, when you square them, they will always be positive, because squaring is multiplying a number by itself. So if you take a negative number, let's say negative 3, if you square it, I'm saying negative 3 times negative 3, and you are going to get a positive answer, which is positive 9. So all numbers, when you square, they become positive. So this is not real. But let's just try to continue solve it. How would we then get M? We would say M is equal to, we'll take this power of 2 to the other side. It will become the root of 2. And we always put a plus or minus the square root of negative 1. Now, what did we say when we talked about the types of numbers? We saw that the square root of negative numbers, those numbers are called imaginary numbers. They are not real. But here they say this guy wants only real. It's saying M is a real number. So we can see that there is no such thing. We can never get a real number from M. M has to be an imaginary number because it's the square root of a negative number. So basically, we can say that A is an empty set. Okay? A is an empty set. We could have it like that. A is an empty set because we don't have any number that is real in this situation. M can never be a real number. Okay, and remember that M is the guys that are in A. So if you can prove that N can never be a real number, you have proved that inside set A, you can't have real numbers. So that will be an empty set. All right, that's just it. We've talked about having an element of a set and the idea of an empty set. Okay, now here's just some point that you could know. You could also have this guy called a singleton set. A singleton set is a set that only has one element. Okay, a singleton set is a set that only has one element. For example, we have this set. This is a singleton set. Or you could have the set with the letter A. This is a singleton set. A singleton set is a set we have with only one element. Now, a doubleton set is a set with two elements, okay? And this would be an example, A, B, all right? Or I could even say A, B. This is a doubleton because remember that listing twice does not give me a new element. This is just two guys, all right? So in actual fact, this other A can go. We'll be left with these two. That's it. Thanks. Goodbye.